So I invite Mathew Varghese to handle the session today. So I hope you all enjoy. We'll begin the session shortly. So please wait for a
Hello,
minute. Yeah.
am I audible? Okay, fine. So I shall be sticking to medium of instruction as English because someone might be not comfortable with Malayalam. So let's start. The why I thought of taking a session on 3D modeling is because as we all know, we are going through this coronavirus thing. Everyone is in this together. So some hospitals have been encountering some shortage of this PPE kits, that is personal protective equipments. And the collector of Patantita, he asked us to prepare some of the PPEs for the hospitals. So we made some face masks, face shields like this. It is 3D printed part, this hairband kind of thing, and we can simply put it on, and if someone sneezes or something, then the particles won't be coming to our face. So this is, we shipped 5,000 pieces in the last 2 to 3 weeks. So that is happening. So what I'm telling does have a real world implication. That's what I'm trying to say. I have been 3D printing since first year of engineering. That is 5 years back. Um, I made a 3D printer that time, and since then I have designed lots of models and made use of all this stuff. So I'll be walking you through the design process of how to design a stand for my mic. This is my mic. This is a Zoom H1N mic, which is used for recording for all this YouTube and all those stuff. So I'm trying to find a real world problem. I have this real world problem, that is I don't have a stand for this mic. Now there is one more issue with this. Like if this mic, if I'm holding my mic or keeping it in the table, then it will be shaking, and that sound will be there in the recording. So that is not required. So we'll be making a mechanism to counter that also. So let's firstly let's just see what 3D printing is and which all modeling softwares can be used for it in a slide, a small presentation. Hope you can see my screen. Can someone ping me? Can you now? I guess you can see my screen right now. Okay, fine. So I have shared my screen, so we can get back to the presentation. So the basic idea is there are many 3D printing softwares, 3D modeling softwares there. Why do we need to learn this? Look, we are in the industry 4.0. The industry 1.0 is like very old machines. Then this industrialization came, and all this cloud and IoT thing came. And now we are in the phase of industry 4.0. As you can see, there are 9 pillars to industry 4.0, like augmented reality, system integration, cloud computing, big data, IoT, 3D printing, cybersecurity, autonomous robots, and simulation. We are focusing on this 3D printing part. Like a few years back, this microwave thing, like the microwave ovens that we use in our houses, these kind of waves are used to find aircrafts in R&D purposes, like radars use these microwaves. So this kind of a very sophisticated technology is ported to our homes, and it is now sitting in a cupboard, or it is sitting on the counter of the table, or in the kitchen. So that kind of a sophisticated technology has been shrunk down and put inside our homes. This kind of a transition is happening in 3D printing world also. So a few years back, when I started 3D printing, there weren't so much printers in our locality, and the maker community hasn't accepted 3D printing as widely as it is now. In the last 5 years, has seen a lot of very people taking up all this 3D printing. So, like that, in a few years, 3D printers will be there in the houses of most of the people. You can simply download some file from the internet and print it. The only raw material you need is a spool of plastic, something like strings of plastic. That is all you need. So with that, you can make all these kind of certain 3D models. So let me get started to this topic. The thing is, the popular 3D printing softwares we have to look at. So this is an essential skill. Essential skill. There is no doubt in it, because you will be printing most of the stuff. If you know how to design, then you can repair all these broken parts, and you can design all these small things that can make your life much easier. So I believe that most of the people here are engineers. So all of them have this acumen for solving problems. So mostly the prime focus is given to computer science field. A lot of people taking up all these, what to say, Python courses, machine learning, artificial intelligence. All these are supplementing this industry 4.0. While it is there, people are coming to this just because it is very cheap to get in. Like it doesn't cost much to get in. Uh, like downloading a Python executable will be like much more cheaper than buying a 3D printer. That's what I'm trying to say. So when these printers are widespread, you it will be an added advantage for you to know these kind of technologies. An example will be maybe there will be someone who will be designing these circuits, and when you want to put it in an enclosure, everything, even this mobile phone, it has an enclosure, right? So you can simply print the body and put the circuit inside. That will be much more presentable, and prototyping all these products will be much faster. What I mean by how prototyping will be very good is, you can think of it like, yeah, in all these products like hard disk, computers, everything is made, these plastic parts are made using 3D molding. Molding means you will be making a mold, something, a negative of the object that you need to produce in a metal enclosure, and you will be injecting plastic into it. That is how most of these things, may take the case of this torch, every shiny part, this all this red part and this transparent part, everything is molded. But molding is not that much useful. Not useful, it is not affordable if you are making very less number of objects. So ideally what you should do is, for prototyping, you should first try a certain number of pieces. In case of this face mask, we went through a number of iterations, and we took the feedback from the hospitals, and they said you should be putting holes here, you should be attaching something to the end of it, and we rapidly changed the models and changed the what to say, the production technology. Like I initially printed with a small nozzle, then I increase the nozzle size. That I'll explain all that while we get to the 3D printer. So first thing first, we have to 3D model this. So in case of 3D printing, the steps are like this. 3D modeling comes first. Like we have to first visualize. We have an idea in our mind. We have to put it into a physical model. So we have to model it in the computer itself. So a certain number of softwares like Fusion 360, SolidWorks, Inventor, Tinkercad, Autodesk, like AutoCAD, All these are there. Blender. Some of these are for artistic models. Some of these are for parametric models, which is like measurements matter in case of parametric models. We'll be dealing with these parametric models. The software that we'll be using is Fusion 360, mainly because it has a free like subscription plan. Like if you're a student, then you can go to Fusion 360 website, upload your ID card, and you can simply download Fusion 360 for free. So Fusion 360 is like a manufacturing, all-in-one manufacturing software in which you can 3D model, you can design the circuits. That all these are being added on top of the functionality it already have. Now they have started supporting 3D printing slicing. That is the second step which is there. Uh, Previously it used to be only 3D modeling. Now it is supporting 3D slicing also. So it is being improved day by day, and it is being given free to all the 3D designers, like student 3D designers, and we can use that to model stuff. So then the next step would be slicing. So slicing is like, we have a 3D model. We have a 3D model of this torch, and every time how a 3D model, 3D printer works is like it will be creating objects layer by layer. It is called additive manufacturing technology. That is because it is adding small uh, quantity of material on top of each other, and in the end it is forming something marvelous. Something like, consider yourself icing a cake, putting icing for a cake. It is like you are pouring substance over the cake over and over until it forms a complete cake in the icing only. So that is how it is being done. So for that, the tool motion in every layer has to be, we have to design the 3D model and these tool paths. So for that, we can either manually write it, or we can use this software. Using this software is like the easiest thing. You just have to put the 3D model and it will be giving us the output file as G code. G code is machine code. It will simply tell X coordinates, Y coordinates, and Z coordinates of where it should go in a text file. We can edit that text file also. Anyways, that is slicing and uploading to the printer. Some printers have this SD card printing. That is SD card that we put in our mobile phones and all, right? USB printing, and over the cloud it can be connected. Now um, I have implemented such a technology over here, and after loading the file, we have to 3D print. Of course, we need a 3D printer, and we have to assemble the parts. So this is uh, what we will be going through today. Okay, our problem is this is the mic, and I have a tripod to attach it. But this tripod is for a GoPro. As you can see, this is a 1 meter long tripod, and it can be adjusted. It can be adjusted like this. We can increase or decrease the length. So I already have something with me, and as you can see, there is a notch on the top where I can insert something and screw. There's a screw for it. As you can see, we can put something here and screw it. So this is what we will be making. In order to do that, we have to know how these studios are using these mics. So we'll be going to the internet and searching, but um, I have looked it up for you, and I found a very good model. That is this one. As you can see, here is a mic. There's a frame, there's a mic stand, there's a frame, there's a clip, and there is a mic holder. It is suspended by some kind of elastic string, it seems. Okay, so we want something of this sort which suspends the mic so that it doesn't move. Fine. Okay. Now, what we'll be doing is we will be diving right into the 3D modeling part, because that is what we are waiting for. For that, we have to launch this Fusion 360. You have to head over, you can simply download it from Fusion 360 download and Simply Google it. I don't have to show it to you. It is, as it is said, it is free for students and educators. So you can just download, sign in with your username and download. You can do that. And I have already downloaded and I have loaded a workspace, as you can see. This is a blank workspace. There is nothing here. So I'll be making use of my. By the way, can you see me also while I am sharing? Can you see my face also while I am sharing? Someone please respond. Okay, fine. Yeah. Okay, I'll be making use of this caliper. This is a digital caliper. You can see all these values. It's something like you have used in your labs if you have gone to +2 classes or engineering. And if it is not useful, then I'll be using this regular steel ruler. And that's it. That's everything that we need. Okay, so I'll be taking the measurement of this. As you can see, this mic has a weird thing over here. This is called a dead cat, and it's not taken from a dead cat. It's artificial only. It's called, in olden times, I think it has been taken from a dead cat tail or something. I don't know. Fine. Anyways, so this is the mic. So we have to there are, the basic approach is the same. Like you have to first model this mic. Even the not the specifics are not needed. You can simply get a rough rectangular block or something in 3D model. Okay, so I'll be measuring the model. It is like i'm I won't be showing the measurements from now on, but I'll be telling you. It is 36 by total length. It is 120. We can take the distance from the screen only, because there will be the dead cat will be covering all these places, right? It's funny though. It's 70. It's 36 by 70. Okay, we got that measurement. We'll be heading over to Fusion 360 workspace. And as you can see, there are lots of tools for drawing stuff like extrude, revolve, sweep, box, cylinder. All these are very small shapes that we have all learned. We can easily comprehend. There are some other functions like modify functions like scale, that is increase the size, shell, like you can remove everything inside, combine, it is like you can join two bodies. So these kind of functions are there. There is no time to go through all of this, because the main purpose is how we approach this thing. Like we learn while we are doing, right? You can see Fusion. There's nothing there, no model there. Can't you see the screen of Fusion? Someone, George, has commented he cannot see. No, you cannot? Okay, fine. I'll be presenting once more. Can you see now? Like, can you see the screen now? Okay, fine. Yeah, sure. Now, we can see that we'll be landing here, the solid workspace. Every time we select a new file, we'll be coming here. This is the work area. Here is the real world kind of thing where we can design all this stuff. Just like in a game. I hope all you have played some kind of games. So there'll be a proper work area. There will be some tools like that. There are some primitive models like box, cylinder, sphere, all these low level mathematics, geometry things, and all these other functions that modifies these objects, like scaling an object, which is like increasing in size, combining, adding, all this stuff. So this is what I have told. What we want to do is we already have the measurement, that is 36 by 70. That is the size. So in order to model that, we have to draw a rectangle. There are many shortcuts for drawing all this stuff, or you can go to S will bring up the search menu, and you can type rectangle. There are certain types of rectangles like center rectangle, 2-point rectangle. Like center rectangle is like you can draw, select the center point of the rectangle, and you can give the dimensions. It is 35 by 70, right? Okay, so we got this. And now we need to know the height. So in order to know the height, you can simply take the caliper and measure it. It is 20. Height is 20. So we can increase the height to 20. That is what I did is I selected and pressed the extrude button, and I gave the dimensions as 20. As you can see, we do have a box right now. It is not visible, I know. So we'll be giving a color to it. It's not the color, we are giving the material to it. Like there are certain materials like leather, cloth, liquid, and all this stuff, mirror, metal, so paint, and we can give something like some punchy color, which should that be maybe yellow. So I'll be giving, okay, there's a paint metallic yellow. Okay, now we can see that the object is yellow, and for aesthetic purposes, there is a small cut in the side of the mic. We can give that also, just for aesthetics. We can select all these corners, edges, like two faces will be joining at the edge. I have selected 4 of them, and I am chamfering it. Chamfering means like you can see what it is chamfering. So you can give a dimension, and it will be cutting the corners of the objects. So we have the mic in hand. Now what do we want? We have to simply design the model like we saw. Like this is the model. So we have to make a structure. How do we make a structure? Let me get back. Yeah. How do we make a structure? Maybe by simply we can draw a circle. So I'll be typing circle. It's a center diameter circle starting from the center, and click the surface in which I have to draw. In Fusion, the main workflow is like you can simply click the surfaces and draw something on that surface. Like modeling in 2D is very easy. You just have to look at only one plane. But in this case, in order to make this easy, every plane can be drawn upon. So I have currently selected this plane and selected the center. And in order for the mic to stand, the outer covering, that the part that we are designing should be greater than, the size should be greater than this mic. So that is what I have done. And I'm offsetting this by pressing O. That is, offset means move, create a copy on the outer side. I have given 1.5 mm diameter. And as you can see, it is over here only. And I'm extruding that by pressing extrude. I need the length to be 7 mm. 7 mm would be okay. Yeah. Now we have something surrounding this mic. We can have the same thing over here, and it will be acting like a support if we put some kind of string between it. Maybe we can put some rubber bands in between. So let's design it like there will be a cross like thing coming with rubber bands. Like we put rubber band in our hands and do all this stuff, right? So we can support it in the rubber band structure. So for that, I need some kind of things, some kind of a small piece protruding from here. So that is what I am thinking right now. So I'll be making that. What is the easiest way to make it? We can draw a sector. Like we already have the sketch that we have done. Like it isn't like in Photoshop only. Like you can see what all bodies you have made. Like body 1 would be um, this yellow block. Maybe we can give some proper names to understand. I'll be giving it main body, or mic. Mic is good. Then this is the body 2, that is the circle support. I am coming up with all these names. That's all. You can give anything. It is not like in programming. You just have to imagine that. So I have to draw something here. So in order to make that, I have to draw in this circle. So now I am drawing in this plane in which this circle resides, as you can see. Fine. So I can draw a circle. I can draw an arc, a radius, and I can select an arc by drawing at some kind of angle or something. Like you can see the angle and the distance is mentioned, right? You can see that. So I'll be drawing a small tab or an arc at 175 degrees. That is 5 degrees. This distance is 5 degrees that I have just randomly taken. And I can extrude this. Fine. I'll extrude this 2 mm. Okay. So I got this small tab, and there should be, this won't work because there should be something to stop the rubber band. It will be wrapping like this arc is wrapping, it will be wrapping like this only. So we need something here, right? Fine. Yeah, it is sketch. Someone have commented that this is sketch view. So we can extrude this part over here, this part. But since this surface is not a plane surface, and this is a plane surface, we can easily extrude that surface as we want, like cut it or extrude it. But this is a spherical surface, and this is also a spherical surface. It is part of the circle only, right? So we have to press pull that. Before that, there's one more thing that you should be thinking of. Like only one rubber band wouldn't do. You had to put it all over this place. So I'll be making this one body and copying it to this circular path, 3 or 4 of them. Okay. So I'm building on this, but these are 2 separate bodies. Fine. To do that, I can either extrude it some more, 1 mm I am extruding, and I am creating it as a new body. You can create bodies as join, cut, intersection. Join means it will be joining to the total full body that it is touching, and cut means it will be cutting all this stuff like this. And I'm making a new body because I want to use it later. Fine. Now we have 2 bodies here, like this one and this one. I can create a stop for this rubber band by press pulling it. I cannot extrude it because it is part of the spherical surface, but I'm press pulling means I'm keeping the surface as it is, but I'm simply increasing the body's length. That is what I'm doing by press pulling. Fine. I'll press pull it to 1 mm. Now you can see a rubber band can easily be situated in this place. Like it can easily hold. Rubber band can easily hold. So I'll be getting rid of this sketch. We needn't see that anymore. Like you can see this, right? Fine. Now we need to join these two. These two are same body only. Not that one. This one and this one. To make that, there's a feature called combine. It performs Boolean operations between solid bodies. Like you can add or subtract. Its combine means usually means join, but you can subtract also. Join, cut, intersect, all these are there. So I am joining these 2 bodies only. So we have something here, right? And we have to copy that. This is, I can rename as feature. Okay, it didn't combine. Let's see what happened there. Yeah, it's joined now. It's feature. I have to put it around the circle, right? I'll be selecting circular pattern. Lucid dreamer asks, press pulling means extrude from side. No, press pulling means like there are some situations where you can extrude. That is like only if it is a plain surface, then only you can extrude. If it is completely flat, but as you can see, this surface is not completely flat. It is part of a spherical surface or a part of a face of a cylinder. So you cannot simply extrude that, but simply you can keep this like the surface as such and increase the length of the body from the surface from which we are pulling it. That is press pulling means. We will see some more um, some more places where we use press pull where extrude cannot be used. Okay, fine. So I have selected the circular pattern and I've selected the object feature. I need to copy the feature. Select the feature and select the axis. We already have a circle. We want to put it all throughout the circle. And the number quantity. We can put 5 of them, right? It's equally spaced, as you can see, 1, 2, 3, 4, 5. Why did I choose 5? Because maybe we should think forward. Like we should be able to put something down here to connect these two circles. That one more we'll be making here, right? So we need something to connect these two circles. So there should be something protruding from here. So we cannot attach this rubber band here, or else I would have chosen 6. Like you can see, there will be one more coming here. The professional mic has 6 of them, but we'll be choosing only 5. Anyways, so we got a model in which there's a 3D model and there are some places to attach the rubber band. So we need the same thing over here, right? Um, but as you can see, the number of bodies has increased. Feature 1, feature 2, feature 3. We can attach all those to this single body. We needn't use the features anymore. So we are joining that to the single body. Fine. Mm, and we only have feature 1. The name has changed. Circle. Fine. Circle is there. Now we can make a copy of this. Select this body, click on create a copy, and voila, we got this. And I should probably move this too because it is on the edge. I don't want the circle to be sitting on the edge. I want it to be the rubber band to wrap it completely. So I'll be moving it here too, like you can see, right? Now we need something to connect these two circles, right? We need something to connect. What can we do is maybe we can put something small or here, or ideally we can make a rectangle right down here, a rectangle piece of plastic which can connect these two, as you can see here. So I'll be creating a plane here. So we cannot just rely on these faces alone in case of 3D modeling, because sometimes we want to go out of the model, go to somewhere else and draw all this stuff. So for that, Fusion 360 has this feature of constructing planes. For this, we are creating an offset plane. We are like creating a rectangle which is below all these circles. So we are creating an offset plane, as you can see, right? So it is a little bit lower to this body. It is perfectly parallel to the mic. And now we have this plane. Now we can start drawing the rectangle. Simply draw the rectangle on this plane. Click on this plane and it will be drawing on this plane only. So it needs to simply connect, that's all, nothing much more. So I'll be drawing a rectangle like this, arbitrary measurement. And I'll be extruding that. Let's give it 2 mm thickness, right? I Now we can see that it is not touching the plates. Like it needs to be touched in more than one place. this part needs to be connected, and the part below, behind that, also need to be connected. What is the easiest way of doing that? Maybe I'll give some other color to this, because it is not visible. I'll be giving, what is it? Transparent. No, not transparent. I'll be red. I'll be searching for some red part. Or, okay, there's a wood part here. We can give that also. Okay, it is a piece of wood, it seems, but um, it's realistic, right?
Wait. Hello? Can you hear me now? Fine. Okay. So I think my headset died. Anyways, let's see here. You can simply click 1, 2, 3, 4 like that to simply change the kind of views that we are seeing. We have been seeing the model view, which is control 4. In control 5, you can see the hidden edges. Every object will have some kind of edges in its back that will be shown in dotted lines. And control 6 is like wireframe drawing. We can see all this. So when I click control 6, you can see that this body, this circle is extending all the way till the bottom. But it is not being shown here. So we can make these two things separate parts, because in printing, you will be laying all this on a plain surface and you will be printing to the top. So what happens is all this area, circle area over here, would have to be supported by something. It cannot be printed in the thin air. So that's why there's a concept that is, when we are designing for 3D printing, you should keep that in mind, that you will be 3D printing it in the end. So we have to model that like. So I am designing these two, this circle and this base, as two separate parts for now, for easily 3D printing. For that, I have to put a gap here. I'll be combining, you can see combine this model, base plate, and this 3D model. And I'll be using cut, so that that portion where the circle meets the base will be cut. And I'll check the keep tools tab, because I don't want to lose this circle after this. Fine. Now, nothing seems to have happened, but when I hide the circle, you can see that there is something here. Like you can see there's a hole here, right? Fine. So that is it. We have designed a base plate and we have done all this. But there is one more thing to do. Like you can see here, like all this is not that good. This is just like a rectangle piece. We can easily save some more material here. So I'll be using some other technique, that is, I'll be drawing a rectangle here and subtracting some pieces from here. I can draw this rectangle without compromising strength. I'll be drawing one rectangle here, which is, and another one here. As you can see, it is equal rectangles only. And I'll be extruding these two. Extruding means I'll be reducing these two materials from that. Now the material usage has been decreased. You can see, right? And I'll be making these edges better. But before that, I'll be applying some other materials. This doesn't look good to my eye. So I'll be choosing something like plastic, green plastic, no, white plastic, beach plastic. Okay, fine. This beach color looks good. I'm choosing all these edges here, as you can see. Appearance, I shall close that tab. Okay. I shall be selecting all these edges so that it is not sharp. And I'll be applying this new thing called fillet. So what is fillet? You can round the corners like this, as you can see. It is much better, right? So most of the appliances that we use, they doesn't have sharp edges because users need something to make them round. They don't want to get pierced or something because of this. So let's put another one, and I'll be giving 5. Okay, much better. We can see the second one has the same features only. So what I'll be doing is, you can see here, we shouldn't have had copied this circle before because we made some more changes. So I'll be deleting this circle too. But before that, we can copy this circle one. I'll be pressing move and selecting create a copy. Oops. We move, create a copy, and I'll be dragging this to align it here. As you can see, there is another circle that we made first. It is circle 2. It is overlapping, so we don't need that. So we'll be simply removing that circle. Fine. So this is it. We have created this 3D model. And there is one thing, we can get back to where we started. Like we need to attach that thing to here. As you can see, there is some finger-like joints. So it is called finger joints in for GoPro. You can search that up. It is pretty common for cameras. So what to do now? You have to model that part separately, right? So for that, we'll be attaching that to the bottom of this. Maybe we can do one thing. We can make that finger joints over here. But can you guess what is the problem that will come? Because we are attaching something like this, as you can see. It will move only in this direction. But sometimes we might have to move the mic to this direction also, or like this, rotate it like this. But that is not possible if we model right onto the base plate. So we need to make something else. What should we do? We shall model something other than this. So let's do this modeling. Now first draw a rectangle. You can select the plane on which you want to draw. Like the plane would be the base. We can put everything in the base, right? So the plane would be this. We can draw a rectangle adjoined to that. Something like the measurements you can take. It shouldn't be bigger than this. So it will be not good if it is bigger than this. So it's there's a problem. So we'll be making an offset plane. we are in the sketch workplace, we will get out and make an offset plane of 2 mm. We just don't need to combine these two modules. That's all. So looking at the bottom, I'll be drawing a rectangle. Clicking this plane will be allowing me to draw in this plane. I'll be drawing a rectangle. As you can see, it, it is between these two places. I'll be finishing the sketch and I'll be hiding the plane. Okay, so we have something here, some sketch here. I'll be extruding that and giving it a height of 2. And it is asking me if I want to join. No, I want to create a new body. Yeah. And as you can see, we forgot one thing. Like we subtracted from this part from this base plate, but we didn't do that for this. Let's do that now. We are combining, selecting the base plate, tool bodies, we are selecting the circle, we are cutting, and keep tools option is set. Okay, done. Now that is done, we can proceed with making this. So in order to make this, maybe we can simply move it out of this way. It is not clear what we are doing here. So I'll be moving it out of the way somewhere far. Okay. You can see there's a part here. And as you can see, I am measuring the distance, setting the 0, and I am measuring the distance. As you can, the distance is 3 mm for the fingers and 3 mm gap between them. There are 2 gaps. So we have to create 2 fingers in this distance. Okay. So now we have to go to advanced sketching. So the sketching is like we can draw in the surface. I'll be drawing a rectangle. Find some arbitrary rectangle and another rectangle. Okay. So there is a thing called dimension, sketch dimension. So after drawing, I can assign the dimensions. So this constraint tab is here, which is used very extensively because after drawing, we need to align these things, these sketches in some places. So for that, simply moving won't do. It is not like you are moving 5 mm all the time. It can be 3.9536 like that. So we'll be mostly using constraints. So dimension is a constraint. I'll be putting the dimension of this after designing. So it is like we can see the dimension is, what to say, 15 mm. So we're putting it as 15. And this too, dimension, shortcut is D. We'll be putting it as 15. And there's one thing, we need to align it at the center. So what to do? As I hover over control, pressing shift, I can see the midpoint of this edge. So I'll be creating a line there. So I can simply create the line by selecting the line tool, and there's a sketch option. There's construction, look at all these options. I'll not be using this line anymore. So I'll be drawing it as a construction line only. Fine. So there is the construction line, and I'll be drawing it to the other end. So we got the midpoint. Now we need to know how much far from the edge or how much from the center we need to move it. So as we have measured, it is 3 mm distance. So 1.5 mm to the top and 1.5 mm to the bottom. So I'll be typing 1.5 and we got a point there. Again, drawing lines from the center, 1.5, right? Fine. And I'll be aligning it here. There's a coincident constraint. As you can see, there's a midpoint of it here. Sorry, I shouldn't have selected that. There's a midpoint of it in this side, and I'll be clicking that midpoint, and I'll be clicking to the point in which that should come. Now, as you can see, it has automatically aligned. I'm doing the same with the other one. I'll be clicking. I shall be putting it. Where is it? Where is the point that we have? Oh, we lost that point, I guess. Line center. Oh no, this is the point. So we shall be clicking that center point, lining it here. Now we got two of them. And simply one more thing to do, like just select it, select these two, and extrude. How much height do we want? How much height? I'll simply measure how much height I can access over here. That is 12 mm only. So I'll be selecting 12 mm, and it has simply extruded 12 mm. But as you can see, it is rounded edge only. So I'll be rounding the edges. 1, 2, and 3, 4. And I'll be, for rounding, what do we use? It is fillet. It is like cornering the edges. Looking at it aesthetically, we can round the edges. There's one more thing. There's a hole down here, as you can see. And it is through this hole that we are putting this screw. So we can measure from the top how much the hole is distanced. So we can see that it is only 6 mm. So I'll be selecting from the top. I'll be drawing on the surface. I'll be selecting construction line from the center and 6 mm. Got it. And I can simply make a hole over here by clicking search and hole. Putting a hole through here, and the diameter can be, you can see the diameter can be 3 mm because the screw that we have is 3 mm screw. No, it is 4 mm screw. So we'll be putting 4 mm screw. At the end, we can hole through it. Fine. Now we got this part also. There is something wrong here. Let us check what is the distance here. 3.56. Fine. We messed up while doing extrude. It only have to be 3 mm. Now it is only 3 mm. We extra added one more amount. Fine. Now we have both these parts. Now what to do? We need to attach it back. How to attach? You can simply search for align. It's hard to just drag around and put it over here. So I'll be clicking the point that I need to align from and to. I want to align to this place, but it went to the other side. So I'll be putting the angle, and you can see it came over the bottom. Fine. We need to put a hole through here for attaching the mic. So we'll need to move this body. It's called connector. We can rename that for easily. And move this body. As you can see, we can offset a bit so that there's a place for us to put a screw through. And in order to put a screw, I need to extrude it here, right? I'll be switching off the base and circle because we don't want to mess up joining with that. So it is there, and we'll be re-enabling them. Fine. Now otherwise what will happen is it will join to the whole body, and we cannot separate these parts for 3D printing. And there's only one more thing left to do. That is to put a hole through here. As you can see, we cannot select the, we cannot select the center point. So I'll be drawing a line by pressing L and selecting the surface. And from the midpoint, I'll be drawing a line across. We forgot to click construction because I won't be using that line anymore. Let's click here and drag till the end. Yeah, we got the line and the midpoint. This is the midpoint. And we can create a hole by simply pressing H. And there's the hole distance, that is 3 mm. I have 3 mm screws only. and we are cutting through that. Now you can see that there is the body and the objects. It can now rotate in this plane also. As you can see, I will show that. Selecting the axis, and we can see it can rotate in this direction also. And in the tripod, someone is Jacob is asking 1.5 is the distance between the rectangles now. 3 mm, right? No, the distance between the rectangles is 3 mm. Yeah, we measured that, right? We measured that the distance between these two fingers is 3 mm. That is why we put the distance as 3 mm. Fine. So we have created it and we have made the model. What now remains is to 3D print them. We doesn't need this model, right? This is just the mic. We can simply um, move it along. But in order to publish it, I can make use of this render workplace. In this render workplace, I can simply render these objects. Like some of these objects um, can have their own properties. As you can see, like the default object in the default material in Fusion 3D is steel, and the circles are made of steel in this model. You can see how the light shines through. Every object has its own property, even the wood and the all these items, how they reflect light, what all textures are on them. They are we can see them only in render workplace, because otherwise it will be like very hard to um, render all this while we are 3D designing. As you can see, in order to reach only this much clarity, it took 49 seconds. So I am stopping the render. This is how we'll be seeing if we are not rendering. So this is how we are seeing all these 3D car models which are super realistic. Fine, all these product models and all. Now we need to 3D print. For that, there is a tab called Tools. In the Tools, there is one called Make, and I'll be hiding the mic here. Fine. And the material doesn't matter, because anyway you can print only with the material that you have. So this being something with a steel, that is not a problem. So there are some options, preview mesh and all those. You don't need to worry about that. Send to 3D print utility. I have put my 3D print utility as custom. That is, I have chosen Cura. Cura is a 3D printing software that is developed by Ultimaker, the 3D printer that most of us have in our college fab labs. So I'm using that one only. Other than that, there are others like Simplify 3D and Prusa slicers. Prusa slicers. All these are different kind of slicers made by different companies, and how they differ is how efficiently they do this 3D printing, how efficiently do they slice the model and all. So this Prusa slicer, maybe we shouldn't go there. We can print with Cura only. Select the model, and if you don't want to send to 3D printing utility directly, you can always uncheck that, send to 3D printing utility. Now, for demonstration, I shall put it to my desktop. Circle 1, okay, fine. The next one I'll be sending to desktop. It is circle 1, fine. There is a base that we need to 3D print. We forgot one thing. During 3D printing, the sizes of these holes and all these things change a bit, because this plastic contracts when it is heated and cooled back. So we need to factor that into consideration. For the circles, it is not problematic in our case, but in case of these places, we have that problem. because the holes need to be very good. Like small tolerance should be there. As you can see here, we cannot extrude because all the faces are looking at different directions. So in that case, we'll press pull this. Point 1 is the tolerance that I use for my 3D printer. It is point 1, it is coming. Okay, point 1. I'll increase the hole size to point 1. Same to here also. I'll increase the hole size. Press pull, and it is point 1. Fine. We're approaching the final stages. Like I'll be 3D printing this, save as base to my desktop, the base part also send to desktop. As you can see, there are some files on my desktop, and I'll be printing them using Cura. So the Cura is loading. Um, how do we export it to use for Spark AR format? Fine. So in this 3D models, there are something like in Fusion 3D, there is this file menu. You can there's an export option. You can either export that as FBX files, that is a package file, which includes all the materials and all the textures. And if you are including some pictures of like decals, you know, right? You can import the 3D model of a car, and you can simply um, simulate some import some stickers and look if it is matching for your car and all. So such kind of decals can be imported. Like if you are making a water bottle, maybe a slice water bottle or water bottle, then you can simply import a banner which shows all the details of the product and wrap it around the water bottle. So that kind of things are exported using FBX and OBJ files. Either of this will work. Now, as you can see, for 3D printing, we'll be using STL files. Windows actually supports this right out of bat. So you can see that there is a 3D model here. And actually, this is made up of triangles. For everything in computer science, there is a representation, right? For pictures, it is represented as a matrix. For 3D models, one of this representation is STL, which is represented using triangles. If I import it back in Fusion 3D, all these faces will be comprised of triangles. Fine. So that is what is happening for different 3D models. I hope you get it, Lucid Dreamer. And that's it. Now we need to import. You can see the Cura is loaded. We can simply import by selecting all those parts, putting it on the bed. It seems complex, but trust me, it isn't. It is very simple compared to making a die. You can simply tinker around. You have printers at Fab Lab and you can use it. You have to, this is the problem that I thought. If you're printing like this, I'll show you what will happen. Let me choose the material generate support. And as printer cannot print in midair, it will be making some support structures here. Like you can see, this is the print view. The material is wastage. All this small yellow material is support material, which is not useful for us. We need only this green part. So we are simply wasting stuff by printing in this direction. So let's go back and see. Yeah, let's go back and just see how we can make this better. We have to rest it in this side. So you can select, rotate, translate, all this stuff. Our tools are here. This is in Cura Workplace. We have got out of Fusion 360. and you can select face to align to build plate. Simply select that and click the face that you need to align. As you can see, when we go to the preview, it is using only very less material, right? It is using only less material because all this unused stuff is not there inside. So we'll be aligning that everything as we need. Same for the other models. It's only logic, nothing complex here. I'll be auto arranging the parts. I can move it around and all. Fine. So I have integrated all this using internet. That isn't necessarily the case. Like you can see, I can control my printer using an IP address like 192.168.1.5 using a thing called Octoprint, and it is connected to my camera. But it is not showing just because um, there is no current in there is no light in the room in which I have kept the 3D printer because the current isn't there. So let's see, we can see the feed here. We can control the machinery using the tool bed. We can send the commands like temperature should be this, the um, printer should move in this direction. That all we can give here. So you can see when we hit print with Octoprint, it will be simply sending those files over to this place. And we can see the files that we are printing. See, simply select that and click print. That's all. That is how it is being done. Or most of you won't be having this automated kind of stuff. So I'll be showing the other workflow. You have to simply select save to file, and save it somewhere. I have chosen desktop, and I'll edit with some text editor, and you can see it is just a set of codes. Let me see. Okay. Let's see, it is just a set of codes which gives G1 X74 Y something E something. So it is like telling the printer G1 means move and giving the axis. X axis should move 74, Y axis should move 42. Like that, we are giving some commands to the printer. Get it right? So that is the only thing. And the start and end, it is a very long, lengthy file, as you can see. It has 60,000 lines of code. It would be very hard if we are writing those by hand. Glad that we have all these slices. Anyways, so you can simply copy that to an SD card lying around, and it's good to go, right? Okay. Now I shall go to the place where there is a 3D printer, and I'll be doing that right now. I'll need some time to, yeah, I'm stopping sharing my screen, and we can all go to the 3D printer room. Let me join with my mobile phone. So that I can, it's in the other house, it's in the outhouse. I've taken that as my workshop. I have a lot of projects lying around. I'll show that too. So we are nearing the end of the session. Let's see, join meeting. Oh man, what just happened? Okay, the thing is, I will log out right now.
My oh man, the mic was mute, right? Can you hear me now? Can you hear me now? Oh God, I will come back. Man, there was no current. I wired all this stuff. Be coming in. There is no current. It is all working from inverter. So let us quickly do this before the inverter goes off. The thing is, this is the 3D printer that I and Arvind have made in FIFAT. These are all the 3D printed stuff. Like it's two bucketfuls of stuff, and 3D printed waste is here. It is like all this unusable waste of particles. Like you can see some failed prints and all. So all this stuff are here. And coming to the printer, like you can simply insert an SD card this side. Most printers work this way, and you can select. Currently, I do not have an SD card because I am communicating through internet. You can see this is the main controller. This is an Arduino only. It is an Arduino Mega based controller, and this controller is controlling all these motors. One for X, one for Z, one for Y, one for X, and there's one more. That is, we are pushing the filament through this. As you can see, this plastic wire is used for 3D printing. This plastic wire is used and it is pushed through a PTFE tube. PTFE is a kind of plastic which has very high melting point, and it is pushed to this hot end. Hot end is nothing but what to say, a heated place where plastic will melt. And there is a small, sorry, I am disorienting you. You have to, I can't reach this place without this phone. So you can see there is a nozzle. It is zero point 0.4 mm only. So through this nozzle, it will be coming. This plastic will be melted and it will be coming. Lucid Dreamer has asked, can we melt and reuse? Yeah, we can surely melt and reuse, but building that machinery is much more costly than simply going to the store and buying this spool. It will come in 1 kilogram. As you can see, there was much more last day.
As I said, I was printing thousands of face shields. Now I have three of them. I've put some colors, like you can see different colors are available. There's blue and there's red, green, and all this stuff. So it is like this. If you want to see some more, there are more spools there, more stuff there, more motors there if some of them fails. So all this stuff are there. Let's not go into all of that. Now, how I am able to control it over internet, I'll show you. This is a Raspberry Pi, the popular credit card sized, what to say, micro small computer it is, and it is connected to a webcam. Actually, this webcam is streaming over internet. Now, if we go to the web page and look, we can see the feed there. The thing is, sometimes these printers are not at all reliable. Sometimes you will come to find just a spool of spaghetti or like noodles laying around, because somehow it will break away from this bed. This is called bed. This place break away from the bed and it will fall off, and that will result in a failed print. Or sometimes maybe this wire will break off somewhere over here. So what will happen is no material will be printing, but the this printer is dumb enough so that it doesn't know that it broke off. There are workarounds for that. We have implemented some of those, but that's very like more advanced thing. Anyways, so this is controlling. Now I have put a print. Oh man, reset. Tune bed size. It will take some time to print. So we use heated bed. This is the bed. It can be heated because hello. Yeah, because different materials have different kind of uh, properties. So some have to stick onto this bed. For that, we have to heat the bed. So there are two heated objects, this bed and this nozzle. Anyways, as you can see, it takes time. It is not something that will be like microwave oven, just click it and it will be starting. You can see the temperature. This is the hot end temperature which is loading. This is 122. And you can see the bed also 33 degrees. So in this room, it is now 33 degrees. And you can set it to 50 or 100 degrees also, but I'm not doing that right now. It is heating up. So when it reaches 205, then we can see how it lays down this plastic and how it works. So that is it for it. I will be showing you some hacks that I have done. Okay, I shall show you this. This is a simple power supply. Like if you're making any kind of electronic projects at home, you can see that these kind of power supplies are costly. This is only a 200 rupees module from AliExpress, and I made a 3D enclosure for it, putting a switch and some wires and a DC jack inside. So it is like very cute small box, but it serves the purpose. This is another thing. This is a what to say lithium ion battery holder. So you can simply take this lithium ion batteries, which is used in Tesla car, as you know. It has a number of lithium ion batteries, and those batteries can be salvaged from some laptops and can be used. This is another thing. I have a lot of mangoes at home. I'll be attaching this to a pole and a string, and it will simply retract like this, and I can grab the mangoes. So this is it is hard to show by one hand, right? It is hard to show, but you get the point, right? This kind of stuff can be made. Now the printer has started printing. Let's see how it goes. You can see the printer is melting this. This motor is rotating. It is pushing the filament. Now the temperature is 205. and it is printing. Fine. So I cannot show you right now how the full process because it is this much slow. As you can see, it's been over 30 seconds and nothing, literally nothing has been formed right now as we are looking. Well, I knew this would happen. Let us go back. How much would that halter cost? Time and materials, just a range. Okay, I will tell that. I'll now get back to my room and I shall assemble, I shall show you how much cost it will have. Okay, fine.
You can hear me, right? I've switched. You can hear me, right? Someone please respond. Fine. Okay. And as you can see, it has 11 gram and 3.71 mm. Meters, 3.71 meters. So let us calculate. Maybe you can go to my website, make priya.space/cost. I have made a simple cost calculator. Uh, I'm not sharing the screen. I'll do that. Present now your entire screen. Screen share. Now you can see right now. Fine. You can see cost per gram can be put as 1 because cost is like 1,000 rupees, and cost per hour you can put as maybe like cost. Usually what I cost is cost per gram is 5 and cost per hour is 35. So the weight in grams, as you can see from this, is 11 grams. I put 11 grams. Time in hours, you can see the time as 40 minutes. So it's 0.4, 40 by 60. I'll put it as 1 hour. Fine. That's the minimum. And you can see the total cost is 90 rupees for this whole thing. For this whole thing, it is cost 90 rupees. So this is how 3D printing works. Now, what I shall do is it will take time for that printing to get completed. I shall show you something. Stop presenting. Yeah. Yeah. I have already printed that stuff and assembled it so that we needn't waste any more time. You can see I have put rubber bands all across the same 3D model. You can cross check that is the same model only. There might be small changes, but it is the same model. Most. It is the same model, right? Okay, you can move in this direction and you can also move in this direction. So what we needed is achieved. While we assembling the mic, you can get an idea of how it is going to work. You saw the whole process. There might be mistakes, but we have to minimize those mistakes. I have attached a screw over here, as you can see. There's a screw over there. And these rubber bands, these are the extra ones. I have glued these two circles to this base. Fine. Now I'll be attaching that to my GoPro stand using the screw. And it is now moving in this direction. And I'll be attaching the mic.
is going to be tough, I guess. Um, let me say it, yes. So you can see I have functional mic which can rotate in every direction imaginable that we need, and we can adjust the height of this tripod, which costs like 500 rupees. And I can now do my podcast or sing a song or something. So that's possible. I will show you another, some more complex. Seems simple, but somewhat complex thing. This page. As you can see, this is my camera. This is a mirrorless camera, and the lid of it was broken. That was the problem. It wouldn't close. That was the problem. So what I did was I 3D modeled this small part over here, as you can see, this small part, and I used it. I sticked it over here so that the battery will be clipping easily, and you can close it. Fine. So the first time what we saw was using 3D printing to create something that we needed. That is using a mic stand. The second thing what we have done is like I've created this, repaired this camera. So these kind of stuff are possible. I regularly use this phone stand, which is a cute looking stand, which is not available in stores. I keep my phone in it all the time when someone is chatting and all, or I'm watching Netflix, because as you know, Netflix is only 200 rupees on mobile. And this kind of usable stuff can be made. You doesn't have to have a 3D printer at home. You can create the models, and you can go to some college or some place where which allows you to 3D print. For example, in I got admission to a university named University of Michigan, and you can see that there the 3D printing is totally free. Anyone can walk into the Fab Lab over there, and they can simply 3D print. That kind of situation hasn't arrived here in Kerala, at least not in these places, but it will soon come. But at that time, you need to be much more ready to use that kind of situations, that kind of opportunities. So that is it. I just wanted to show you my workflow, how this can be done. That's it. So what was the total time and cost? I told you, right? The total time and cost I calculated. It is only 100 rupees. You can go to make3a.space/cost. I put the link. I put the link. You can simply calculate how much all this stuff cost. Fine. So that is it. Maybe next day someone will come with a workflow on how they will be doing stuff. Maybe 3D designing, or maybe now I have shown you 3D printing. Maybe someone will come with app designing. The thing is, just looking at these technologies, it is like it's much easier, and some technologies might seem it's much harder, but there's always a way of approaching whatever it is doing. Consider a VLSI designing. So in that case, it is all looks like black magic, but there's a proper steps to make all this. Everything is logical. It's only human beings that are making all this stuff. So I guess this session was very much useful to you. Um, until next time, see you.
Thank you. Thank you guys for attending. Thank you, Chechi. Thank you all. Thank you, Mathew. Thank you, Mathew, for this wonderful session. Okay, thank you. See you guys in the next session. Thank you.
Hello.
Yeah, fine. സംഭവം ആ
കേൾക്കുന്നില്ലേ?
ഓക്കെ പോവാം.
പോവാം. ബൈ.
ശരി ബൈ.